So in section 8.4, there's really not a whole lot different. There's just a little bit of vocabulary with what we call angles of elevation, which are horizontal. You're basically looking up. So this dog would be looking up at the bird at an angle of elevation of, and let's just suppose that that angle created where his eyes tilt up to the bird, let's suppose that was a 42-degree angle, so go put that in there. That would be called the angle of elevation from the dog to the bird. Also up here though, along the horizon, we have the bird looking straight up. When the bird looks down, we call that an angle of depression. So notice that that angle of depression isn't really in this right triangle right here. And what we do is we see that we've got these parallel lines, basically the horizon and along the ground or along the horizontal. And from chapter 3, we know that when parallel lines are cut by a transversal, alternate interior angles are the same. So our angle of depression and our angle of elevation would be the same up there. What that allows us to do is find missing pieces. So suppose I'm going to go erase this now. That was just some vocabulary. But suppose I only told you the angle of depression of the bird to the dog. Okay, so that's again with the horizontal. This, let's suppose it's 36 degrees. Okay, the bird's angle of depression to the dog. And then let's suppose that I tell you that the distance from the dog to the tree is maybe, I don't know, let's say 11 feet. And suppose we're looking for the height of that tree. Okay, so I'm going to put a little X up here, but notice in order for me to get it, I really have to go down to the ground level and see what the dog's height is, or the eyeball level, which would be 3. So whatever I get over there for X, I'm going to have to add 3 to it to get the height of the tree. Well, here's my right triangle. I'm sitting just a second, I'm going to grab a highlighter here so you can focus on the right triangle that I want you to focus on. So my right triangle is right here. And notice that angle of depression is technically not in it. But what we do is we say, well, if it's 36 degrees for the angle of depression, then this angle of elevation is the same. And that allows us now to set up our trig ratio that deals with the opposite side and the adjacent side. So we would do what we've always done. We'd say the tangent of our 36-degree angle is opposite over adjacent, which is 11 feet. We always multiply by that denominator, so you would go to your calculator and do that, okay? But when you're done, you'd have to add 3. So we always just need to draw that triangle. We have to kind of be careful that we get everything labeled correctly. So I have a building that is 20 feet high. Doesn't need to be fancy, but I need to put the 20 feet on a vertical lane. At a distance away from the building, it doesn't say left or right, so it doesn't really matter. So because I'm over here on the left side of my screen, I'm going to go over here to the observer, noticing that the angle of elevation from the ground, so not from eye level or just from the ground, the angle of elevation, so we're looking up to the top of the building, is 31 degrees. So I'm right in there in that triangle. How far is the observer from the base of the building? Well, here would be the base of my building. My building right here, maybe put a door, right? How far from the base is down here on the ground level? So that would be my X. So again, I have opposite and I have adjacent. So this would be a tangent setup. The tangent of my 31-degree angle is equal to the opposite over the adjacent. We always multiply by what's on the denominator, in this case an X. So when I multiply both sides by X, the end result is it cancels over on the right-hand side. So I have X times the tangent of 31 degrees, which is a number, is equal to 20. So for me to get what x is, I'll have to divide by the tangent of 31 degrees. So I'm just going to go 20 divided by tangent 31. And I get a 33.29. All right? So, and that would obviously be labeled in feet. So let's go take a look at my next one. We are 80 feet from a tree, right? So I'm going to have a tree. Whoops, sorry. I'm trying to scroll a little bit, but it's not allowing me to. I'm not really sure why. Whatever. I'm going to have to do a little bit smaller picture here just because. Maybe I'll do it over here. I'm 80 feet from a tree. So let's go over here and draw my tree. Not quite sure what's going on here. I don't know what's going on. Oh, at least I got purple. This is really weird, but I'm not starting the recording over again. So here's my tree. I must have hit an annotation tool. It says I'm 80 feet from it. So let's put me over here. 80 feet from it. Here's the root right here. I don't know why I have this annotation thing. I'd like to be rid of it, but I don't know what button I put. Oh, exit drawing. Let's try that. I must have hit drawing of some sort. Sorry about that. I'm not starting the video over again. So we're going to start over. So I'm 80 feet from a tree. Tree, here you are. Lerood over here, 80 feet from the tree. All right. It says the angle of elevation from my eyes. So I'm going at eye level. So I'm going to go horizontal with my eyes. The angle of elevation to the tree is 77 degrees. Okay, so that's the angle of elevation. So I'm right in that triangle to the top of the tree. It also says my eyes are 4.5 feet off the ground. So this is 4.5 feet. So is this distance right here. So I'm going to label this x, and I'm going to know that when I find it, I need to add that eye level height of 4.5 feet onto it. All right? So let's go take a look at what else we have here. It said I'm 80 feet from the tree, so that's this guy down here. So again, my right angle, my hypotenuse is not going to be a part of this problem. Another tangent question. A lot of these are. So I have the tangent of my 77 degree angle is equal to the opposite side over the adjacent side. Again, opposite that angle is the x, adjacent or next to it is the 80. The hypotenuse is not used in this problem. So I multiply both sides by 80. The only thing I have to keep in account is that I started this at a 4.5 foot eye level. So when I do my 80 tangent 77 on my calculator, and I get 346 point, let's say 5, what does it say around to? Hundredths, right? That's the x. But keep in mind, I need to add this 4.5 on because I started this at eye level. So we would add our 4.5 feet onto that. And that would be our final answer. So your assignments in Delta Math, you just have to be careful with drawing those pictures. So I'm going to put up an example of sorts up here for you guys. I don't know why that is, where that annotation tool came from. I must have clicked on it by accident. Anyway, so suppose there's one in there in the Delta Math. We did the first two together, but you're fine. Just be careful whether you're starting something at eye level and you have to add that on when you're done. There's one where there's going to be somebody flying a kite. Well, suppose that their arm level, boom, so they let this string out. Suppose this height right here is, let's suppose it was like 3 feet, right? And it might tell you that the angle of elevation, and again, that's with the horizontal. So this, the horizontal from where you're starting it. So this would be my angle of elevation right here. Suppose it was, say, 32 degrees. And suppose they said you let out, I don't know, 200 feet of string. So the string would be the hypotenuse. So here's my kite, right? And I'm going to go, again, use my trick to find this x distance. So again, we go with the horizontal. If it says angle of elevation from the ground, then I just go from the ground. But this is from where the guy is holding the kite, which is already 3 feet above the ground. So again, my trig function on this one, I do have the hypotenuse, because the string of the kite would be the hypotenuse. So this would be a sine function, right? I'd say the sine of my 32 is opposite over hypotenuse. And I'd solve that for x, and that would give me this. But then I have to tack on that extra 3 feet that it's being held up from the ground level. Okay, so your delta math is, in there it says make sure you show all your work on a separate sheet. Have a good one.